keep watching the videos. Tell your friends to also watch the videos. And that will urge me to bring more videos. Please subscribe to the YouTube channel. Turn on the notification once you do that. Like my Facebook page, alright? The Facebook page is DJ Physics Classroom. Like my Facebook page and share the video when I post it on the Facebook page so that other people will also get it and watch it. So we'll look at another device that we call the gold leaf electroscope. Now the gold leaf electroscope is an instrument which is used for studying the behavior of electric charges. Which behavior are we talking about here? It is used for the following purposes. One, it is used to detect whether a material is a conductor or an insulator. So for instance, I'll pick this material. I want to know whether it's a conductor or an insulator. I can use the gold leaf electroscope to do that. Two, it is used to determine whether a material is charged or not. Three, it is used to determine the kind of charge a material is carrying, whether a material is charged positively or charged negatively. Then four, it is used to measure electric potential, but that one needs to be connected to some other devices, so we may not look at that into details here, but it is one use. Then we also say that it is used to measure the magnitude of charge on a body. So these are the uses of the gold leaf electroscope. So the structure of the gold leaf electroscope is like this. In exam, when you are asked to sketch, to draw, make a label diagram of the gold leaf electroscope, this is what is going to be expected of you. The gold leaf electroscope. So this is brass cap. This is an insulator, insulating cork. That is what separates the brass rod from the metal keys. So this is brass rod. This is the gold leaf. This is brass plate. This is metal piece. Then we have glass in front. Glass in front. Then there is some earthing which is always connected to the body to prevent electric shock. To prevent electric shock, to make sure that the case does not possess any electric charge. If the case, the metal case possesses electric charges, it may interfere with the charges here. We may not see what is happening to the gold leaf. So we make sure that the case is always earthed to prevent it from getting charged. Good. So this is the gold leaf electroscope. And its parts. So when you're asked to draw and label the parts of the gold leaf electroscope, this is what will be expected of you. Good. I have already given you the use of the gold leaf electroscope. So I'm going to run you through some of the uses, the uses one after the other, how we use the gold leaf electroscope to do these things. So let's continue. So we have the brass cap, insulating cork, the brass rod, glass in front so that we can see what is happening to this, the gold leaf and the brass plate, then we have metal case. These are the parts of the gold leaf electroscope. Now what happens is that When you pick a gold leaf electroscope and it is charged, it means that this is how it will be like. When an electroscope is charged, this is how it looks like. The gold leaf has opened, it has separated itself from the brass plate. But when we pick a gold leaf electroscope and it is not charged, this is how it looks like. In this case, we say the gold leaf has opened. We say it has diverged. In this case, we say the gold leaf has collapsed. It has closed down. So when you pick the gold leaf electroscope and it is like this, it means it is uncharged. It is uncharged. When you pick it and it is like this, it means it is charged. Charged. So this is a charged gold leaf electroscope. This is an uncharged gold leaf electroscope. So we want to determine whether a material is a conductor or an insulator. So what we do is that we pick our gold leaf electroscope, but we make sure that the electroscope is charged. So we pick a charged gold leaf electroscope. If it is charged, then it may probably have negative charges or positive charges. So when the electroscope is charged, the reason why the gold leaf opens is because there are like charges on the gold leaf and the brass plate. So the presence of these like charges is what causes the gold leaf to open up. There's a portion between the charges on the gold leaf and the charges on the brass plate. And because the gold leaf is just a foil, it can easily move in or out. That's what causes it to open like that. So this is a charged gold leaf electroscope. Okay, now we want to determine whether this material is a conductor or an insulator. So we have already seen that the electroscope has opened, right? The electroscope has opened. So we bring the material on top of it, like this. The material that we want to determine whether it's a conductor or an insulator, we bring it on top of this. If the material is a conductor, we expect that the material will conduct the negative charges down here up, because if it is a conductor, the material is a conductor, it will attract more negative charges to the top here, to attract more negative charges to the top here, like this, to attract more negative charges from down here to the top. That is because there is going to be separation of charges. The positive charges will be separated and will be brought close to this, and the negative charges will be repelled at the top here in the conductor in attempting to charge the conductor, alright? Good. So when this happens, the gold leaf will collapse like this. So when the gold leaf collapses, then it means that the material we have brought on top of it is a conductor. The material is a conductor. However, we bring the material close to the brass cap and nothing happens to the gold leaf. The gold leaf still stays opened. Then it means that the material we have brought here is an insulator, because it cannot separate charges. Because this material was able to separate its charges, the negative charges were attracted to the top to cause the gold leaf to collapse. It means this material is a conductor. However, if nothing happens to the gold leaf, then it means that this material is an insulator. Good. That is how we determine whether a material is a conductor or an insulator. Then we look at another use. We want to determine whether the material is charged or is uncharged. So we pick this material. We don't know whether it is charged or not. So we want to determine whether this material is charged or is uncharged. How do we do that using the gold leaf electroscope? This is what we do. So in this case, we don't charge the gold leaf electroscope. So we pick a gold leaf electroscope which is uncharged, like this. The gold leaf electroscope is not charged. And then we bring the material on top of it. The material we want to determine whether it is charged or not. If the material is not charged, if the material is not charged, nothing will happen to the gold leaf. The gold leaf will neither open, it will still stay collapsed like that. Then it means that the material is not charged. However, when we bring the material close to the brass cap and the material is charged, let's suppose that the material is charged negatively. It means that positive charges are going to be repelled from the brass to the top here. Negative charges will be repelled down in attempting to charge the gold leaf electroscope. Then this separation of charges will cause the material, will cause the gold leaf to open. When the gold leaf opens or diverges like that, then we say that the material we have brought on top of it is charged. Because it is only a charged material that can induce electric charges, induce opposite charges on top, and repel negative charges down here to cause the gold leaf to open. Good. So now, we know how to determine whether a material is charged or not. We know how to determine whether a material is an insulator or is a conductor. We want to look at the last thing. Now, we want to determine whether a material is charged positively or the material is charged negatively. So we want to determine the kind of charge a body is carrying or the kind of charge on a body. In this case, we charge the gold leaf electroscope. We charge the gold leaf electroscope. And we must know the charge on the gold leaf electroscope. That's very important. The gold leaf electroscope must be charged, and the charge on the gold leaf electroscope must be known exactly. Good. So let's suppose that the gold leaf electroscope is charged positively, like this. The gold leaf electroscope is charged positively. Now we want to determine the kind of charge a body is carrying. So we bring the body close to the brass cap, like this. If the body is charged negatively, let's suppose that the body is charged negatively, it means that more positive charges are going to be attracted to the top. More positive charges are going to be attracted to the top. Leaving no positive charge down here, then what that means is that the gold leaf will collapse. The moment the gold leaf collapses, then we conclude that the charge on the conductor, the charge on the material is of opposite charge to the charge on the gold leaf electroscope. Since we know the charge on the gold leaf electroscope as positive, then the charge on the material is negative. It's as simple as that. It's as simple as that. So to do this, the charge, we must charge the gold leaf electroscope, and the charge on the electroscope must be known. Good. However, let's suppose that we bring a positively charged body on top of this one. So the gold leaf is charged like this positively. When we bring a positively charged body on top of this, the positive charge here will repel the positive charges on top of the plate and bring them down. So when the positive charges are repelled down, then the gold leaf is going to open more. See, the former position of the gold leaf was like this. Now the new position of the gold leaf is this. Alright? What this means is that the gold leaf has now opened more, because more positive charges have been repelled down here. So further divergence or further increase in the angle of the gold leaf shows that the charge on the conductor, the charge on the body, is the same charge that the gold leaf is carrying. So because the gold leaf is charged positively, then the charge on the body is also positive. This is how we determine whether a material is charged positively or a material is charged negatively using the gold leaf electroscope. Good. Thank you very much. See you again. It's your 1BG.